Hi everybody, welcome back. Here I'll be trying to solve some of the problems on reduction formulas, which is on integrals of sine and cosine. Okay, let us see those problems here. As we have discussed a few problems in the previous sessions, which I have been uh, doing it, and let me continue. For sine and cosine, we have done it. So let us look into the combining these two trigonometric functions, which is sine and cosine. Let us see those kind of problems here. Okay. Now, now we have the reduction formula, which we would like to uh, get it. So integral of sine, you have sine to the power of m x cos to the power of nx and dx. Okay, so let us obtain this reduction formula here. Okay, so let me write this in the form of I m n, where I is the integral notation which we have, and m and n are the powers of sine and cosine. Okay, so now let us continue solving this problem here. Now I m comma n is equal to integral sine to the power of m minus 1 x into sine x and cos x in x dx. Okay, what I have done is multiplied and divided by sine term here. So I get this. Okay, now this is like uh, u into v. Let us integrate it. Now I can write this as sine to the power of m minus 1 into x. Okay, and integration of cos to the power of n, and we have to take this. So if you represent that as t and then afterwards try to simplify it, I get this result as cos to the power of n plus 1 divided by n plus 1. Okay, into x. Okay, so this is done. Now minus integral, this would be differentiation of this would be m minus 1 into sine to the power of m minus 2 into x, and multiplied with now integration of that, which I get as minus cos to the power of n plus 1 into x divided by n plus 1. Close it. That is minus cos to the power of n plus 1 into x, which is a function of x, in divided by n plus 1 and dx. Okay, since it is in integration. So let us further simplify this, where uh, it makes easier, okay, to understand. So m minus 1 x and cos to the power of n plus 1 x, and this is minus divided by n plus 1. Okay, if I simplify all those things which are there, okay, further, so I'll get minus, and minus it is plus, so this is m minus 1 divided by this is n plus 1 integral sine to the power of m minus 2 x into, now this should be cos to the power of n x. Okay, so now cos square is 1 minus sine square x, so that I'll be writing 1 minus sine square x and dx. There are other ways or other methods to solve this. This is one of a kind. Okay, so further, if I try to simplify it, okay, so this can't be done further. So I get minus sine to the power of m minus 1 into x and cos to the power of n plus 1 into x. This divides by n plus 1. Yeah. Now I can write this as m minus 2 to the power, that is, we have considered as m and n, like that we can consider m minus 2 and n here, because the powers are like this. So I can consider that. And I'll get another term also, which is m and n also. So these two terms will be there. So first I'll write this. Okay, so this term would be I m minus n m minus 2 and the other term, because if you see the powers m minus 2 and plus 2, minus 2 plus 2 gets cancelled and I'll be having only power m. So that and minus of m minus 1 divided by n plus 1. So I m comma n. So that's what I get. So this is for I m comma n. Now we have this term here also here. Let us try to simplify further. Okay. You try to bring it on the left hand side and then afterwards simplify this. I get, or I arrive into this formula I m comma n minus sine to the power of m minus 1 into x cos to the power of n plus 1 into x divided by m plus n. And we have other term also here, plus m minus 1 divided by m plus n. Okay, I m minus 2 comma. Okay, so this is a reduction form. Okay, for sine and cosine. Let us see the reduction or the evaluation of uh, integral 0 to the power 0, 0 and pi by 2 sine m x cos nx dx. Let us see this. Now we got this result earlier, so that would be sine m minus 1 x cos n plus 1 x divided by m plus n over the limit, which is 0 to pi by 2. Plus I have this term also, and I am and there. So this tends to 0. This results 0. So I'll have only m minus 1 divided by m plus n. This is I m minus 2 comma n. Now let us arrive these formulas. This is for I, that's what for the integral, which is 0 to pi by 2 sine m x cos to the power of n x dx. Okay. Let us obtain those results for I m minus 2 comma n. So that would be m minus 3 divided by m plus n minus 2. Okay, for I m minus 4 comma n. If I want the result for m minus 4 comma n, again this should be m minus 5 divided by m plus n minus 4, and this is I m minus 6 comma n, and so on. Now I get now if you look into this, I 3 comma n would be 2 divided by 3 plus n I 1 comma n if m is odd. Okay, 2 comma n, so this would be 1 by 2 plus n I naught comma n if you have m as even. So let us find even what is I1 comma n here. Also we need to find I0 comma n also. I1 comma n would be integral 0 pi by 2 now power 1, so m is 1, so here you get sin x and cos nx dx. So this would be, now when you substitute cos as t something like that, so when I arrive into this, okay, so I get, so minus cos n plus 1 into x divided by n plus 1. Now this is for the interval 0 to pi by 2, so which is equal to 1 by n plus 1. Now we have got for I1. Likewise, let us find I0 comma n. That would be integral 0 pi by 2. This is cos to the power of n dx. So we have already found that, that is for n minus 1, n minus 3, n minus 5, okay, into 2 divided by n into n minus 2, okay, n minus 4 and 3. When you have that, then n is odd. Okay, now you will have n minus 1, n minus 3, n minus 5 and 3 into 1 divided by n into n minus 2, n minus 4, and so on, into 2 pi by 2 when n is even. Now, using all these, let us arrive into uh, the complete reduction formula here. Now, since you had uh, m and n factor also here, which are supposed to you are supposed to put. So we have three different cases. Okay, uh, for that. Before that, I will write I m comma n. That would be m minus 1 divided by m plus n. Okay, into m minus 3 divided by m plus n minus 2. Likewise, m minus 5 divided by m plus n minus 4, and so on. So that is 2 divided by 3 plus n I 1 comma n. This is for when you have m is odd. Let us put this result also, m minus 1 divided by m plus n, and m minus 3 divided by m plus n minus 2, so on. We have this is 3 into, sorry, this will be 1 divided by 2 plus n I 0 comma n. This is for m being an even. Okay, so we have, as I mentioned, we have three cases here. Let us write that down here. So we have three cases here. That would be, if I consider the case 1, okay, m is odd. M is odd and n is even or odd. So let us write that I m comma n, which would be m minus 1, m minus 3 into 2 divided by m plus n, and m plus n minus 2, so on. You have, and we'll have 3 plus n here into 1 by n plus 1. Correct? Let us write down the next case here, case 2. When you have m as even, okay, and n as odd. So let us write down I m comma n, which is m minus 1 into m minus 3, and you have m plus n, m plus n minus 2, so on, and 2 plus n. And this is multiplied with n minus 1, n minus 3, Okay, and 2 divided by, you have n into n minus 2, and so on. The last term would be t. Let me write down the third case also. Yeah. So what would be the third case in cases? Now the third case would be when m and n both are even. Okay, the case third, when have m and n which are both even, which are both even. So that would be I m comma n m minus 1 into m minus 3 and multiplied with 1. Okay, so m plus n, m plus n minus 2, and would be 2 plus, and this is multiplied by n minus 1, n minus 3. Okay, and 3 into 2 into 1, so n minus 4. The last term would be 2, and this is multiplied by 2. So these three cases will imply for sine and cosine. Okay, so let us look at some of the problems here. Okay, based on this. Let's see some problems on this. So if I have integral of 0 to pi by 2, 0 to pi by 2, sine over 7x cos to the power 4x dx. Let us try to solve this. Now m is 7 here. Okay, n is 4 here. So m being odd and n being an even. So we have, that is, that is 6 into 4 into 2 divided by 11 into 9 into 7, okay, into 1 by 5. So which results to 16 by, when you try to simplify, 155. So this will be the result here. Let us see one more example. Okay. Let us change the powers here. Suppose if I have 15 here, 15, and cos q. Let's try to solve this. Now, here you find m as 15, n as 3. Okay, so m being 15, which is odd, and n also being 3, which is odd. Both are odd here. So I 15, 3, that is 14 into 12 into 10 into 8 into 6 into 4 into 2 divided by, this will be 18 into 16 into 14 into 12 into 10 into 8 into 6, okay, and into 1 by 4. So I can cancel these and cancel these, okay, so as well as these, okay, so I'll be left with only 1 by 144. So that will be the solution. I hope you understood this. We'll see one more example. Okay. Let me write that. Okay. Suppose if I have integral 0 to pi by 2. Now you have sine power 6x and cos power 5x dx. So here m as 6 and n as 5. So you will have I 6 comma 5. So that would be 5 into 3 into 1 for the numerator, and in the denominator I'll have 11 into 9 into 7. Okay. So m being even and n being odd, and it multiplies with 4 into 2 divided by, I will have 5 into 3. So when I get this result, if I simplify it, I get 8 divided by 693. So that is the solution. So let us see one more example. Let us see one more example here. So if I have integral 0 to pi by 2, okay, sine power 8x and cos power 6x dx. So m is 8 and n is 6. So both are even. So you have I 8 comma 6, which is 7 into 5 into 3 into 1 divided by, you have this as 14 into 12 into 10 into 8 into 5 into 3 into 1 divided by, you have 6 into 4 into 2 and multiplied by pi by 2. So if you look at this, so you have the cancelling term here, right? You can cancel these 3, okay, twice, fine, this twice here, and this 3 again, this 4 times, okay, yeah, and try to get the final result, which is 5 divided by 4096 and pi. So that will be the solution. I hope you have understood this these things, and we'll try to do some more problems. Thank you for listening.